Alright, here we're going to be talking about proving congruent triangles. So we've talked about a bunch of theorems that are used to prove triangles are congruent. Now we're going to actually be using them in a proof. Before we get into that, let's review some of these definitions and the reflexive property, because these are going to be really useful in these proofs. The definition of an angle bisector. A line is an angle bisector if and only if it divides an angle into two congruent angles. So this line, or really just a line segment here, PO, is a bisector of this angle. It splits that angle directly in half, making this angle and this angle congruent. So PO bisects angle AOB, then AOP, this angle, and this angle POB are congruent. An angle bisector splits an angle directly in half. A segment bisector splits a segment directly in half. This is our segment. That's getting split in half by this line. A line is a segment bisector if and only if it divides a segment into two congruent segments. So this segment is getting split into two congruent segments here. So we could say that CD is a bisector. So if CD bisects AB, then AM is congruent to BM. Last one's really similar to a second bisector. It's called a midpoint. Definition of a midpoint is really similar because it's actually the exact same, except it's just not a point. It's just not a line, it's a point. A point is a midpoint if and only if it divides a segment into two congruent segments. So M is a midpoint because it splits AB directly into those two congruent segments. The last one is the reflexive property of congruence. All geometric figures, in this case we're talking about angles and sides, are congruent to themselves. So we have these two triangles. We have this red one and we have this blue one, and angle ACE, that angle, is a part of both of them. So at times we're going to need to use that reflexive property to say that that angle is congruent to itself, and it's a part of both the red and the blue triangle. Same thing with segment BD. It's a part of this triangle ABD, and BCD. It's a part of both of those triangles. So when we're trying to say that we have a congruent side that's in this triangle and in this triangle, we could use BD because it's directly in both triangles. It's congruent to itself. That is called the reflexive property. Alright, so let's get into some of these proofs. Side, angle, side. So we're actually just going to go through this kind of slowly. We're going to go through each theorem and use a proof with that theorem, or complete a proof using that theorem. And then we'll see how these are related to each of those. So side, angle, side. We're talking about a side, another side, and an angle that's sandwiched directly in between those two sides. So if AB is congruent to DE, angle B is congruent to angle E, and side BC is congruent to side EF, then triangle ABC is congruent to triangle DEF. So if we can get to these three statements, if we can show that we have a side that's congruent to another side, an angle that's congruent to another angle, and the next side over is congruent to that next side over, then we could say that these two triangles are congruent. Alright, so we are given that JM is congruent to NL. JM is congruent to NL. JMN is congruent to LNM. We want to prove that these two triangles are congruent. Alright, so first off, let's just say those given statements. And now think about what other thing we need. This is a little bit suggestive also. We're told exactly what we're going to use here, side, angle, side. You're not always going to be told what theorem we need to use to prove this. So you're going to need to think about a little bit outside the box here, but right now we know we need side, angle, and then the next side over. So we know we're talking about this MN, that side is going to be congruent to itself. It's in both triangles. So it is that third side, or really the second pair of sides that we need by the reflexive property. All right, so now we have side, an angle, and a side. Now we can say that those two triangles are congruent. By side, angle, side. And I'm always okay with you just abbreviating it with SAS there. All right, the next one is side, side, side. So that's showing that all three pairs of sides are congruent. So we're going to write out something very similar to the previous one. AB is congruent to DE. BC is congruent to EF. And AC is congruent to DF. If that's the case, if all three pairs of sides are congruent, then the triangles are also congruent. Alright, so here we're told that PQ is congruent to ST, QR is congruent to RT, and that R is the midpoint of PS. So first off, let's just say our given statements. That provides us with two pairs of sides that we need. Now we just need that third pair. So we need to show that this side is congruent to this side. And that's coming from that last given statement. R is the midpoint of PS. If that's true, then these two segments have to be the same. Then PR has to be congruent to R. Sorry, I said that backwards, but SR doesn't really matter. Those two sides have to be the same by the definition of midpoint. And so now we have all three sides congruent, so the triangles have to be congruent. All right, I'm going to have you try those two on your own. I'm just going to skip right to, actually you're going to try those 6 on your own. I'm going to jump to angle, angle, side. So now we have two pairs of angles that are congruent, and then not the included side, not the one that's in between them, but either of these two. It could be AC and DF, but here we're just choosing BC and EF. So BC, oops, nope, gotta write it in the right order. So if angle A is congruent to angle D, angle B is congruent to angle E, and then BC is congruent to EF. That's an angle, angle, and a side. That would show that those two triangles are the same. So we're given that YZ bisects angle WYX. So YZ bisects WYX. That means this angle and this angle have to be the same. So a lot of times I'll just write all my given statements and then figure it out from there. But since I have a direct conclusion from this, that's telling me that these two angles are the same. That's telling me WYZ is congruent to XYZ. I'm just going to write it here. I'll deal with my second given statement here in a little bit. But for right now, I know that directly concludes that these two angles are congruent. So I'm just going to put that in the next line. That's by the definition of a bisector. Definition of an angle bisector. Now I'm going to say my other given statement. That's saying YWZ, this angle, and YXZ, this angle, are the same. And again, since we know that we're looking for angle, angle, side, this is a little bit easy, but sometimes you won't know exactly what you're looking for. So you have to just think of the 5 options that you have, which one could you use here? So since we know we're looking for angle, angle, side, we know it's talking about YZ. That has to be the side we're showing is congruent to itself. YZ is congruent to YZ by the reflexive property. And that's all we need. We need an angle, and a side that's not sandwiched in between those two angles. So angle, side shows that triangle WYZ is congruent to triangle XYZ. Right, angle, side, angle. Same kind of thing. We have two angles, except now we do have that side that's sandwiched in between them. So we have an angle A congruent to angle D. Side AB is congruent to side DE. And angle B is congruent to angle E. So once again, ABC is congruent to DEF. So here we're given that SQ, this line segment, bisects RQT and RST. It's going to bisect both of those angles. That's going to help us to conclude two things. This angle is congruent to this one. Remember, a bisector means it's splitting that in half, so these two have to be congruent. So it's RQS is congruent to TQS. And same thing on this side. RSQ is congruent to TSQ. Both of those are by the definition of an angle bisector. And now we need a side in between those two. For angle, side, angle, we need the side that's sandwiched in between these two angles, so that is QS. QS is obviously congruent to itself by the reflexive property. So we have QRS is congruent to QTS by angle, side, angle. All right, one more. It's called hypotenuse leg. And there's already an assumption when we talk about hypotenuse in there. That means we have a right triangle. So it's not even really just these two pieces of information that we need. We need a hypotenuse and a leg that are congruent to each other. But given that we have a hypotenuse, that means we have a right triangle, so we have the right angle. A hypotenuse is always directly across from that right angle. So that's the side we're looking for the hypotenuse. So that's BC. It's congruent to EF. And then the leg is either of these two sides. It could be AC is congruent to DF. Here we just happen to choose that AB is congruent to DE. So once again, ABC is congruent to DEF. All right, so let's first off say that we have some right triangles. This given information could show up in a few different ways. So we could say that these are right triangles. We could also just say that these are right angles. MPL, we could say that that's a right angle. That would accomplish the exact same information there. We could also sometimes be just given this picture, and then we'll have to write that as a given statement, that MPL. So let's say there was no statement here at all. Then we would have to say MPL is a right angle, and MPN is a right angle. And it would still be given, but it's just given by the picture instead. I've always learned that you need to be given statements to use it as given information. But from practices I've seen, from even resources that the state has shared with us, it's clear that the picture is going to be used as given information. All right, so we have right triangles. We also have that ML is congruent to MN. So that's the hypotenuse. That means we just need a leg, which is that shared side in the middle. MP is congruent to itself. Again, by the reflexive property. And so, by hypotenuse leg, we have two congruent triangles. Alright, that was a lot, but I feel like once you have your direction, once you know which one you're going for, then it's just a matter of showing the three things that you need. You need right angles, you need congruent hypotenuses, you need congruent legs. Once you know which direction you're going with it, once you know which theorem you're going to use, then you just show that each of those pairs are congruent, and you say which one you used. Alright, I hope this helps. Try that you try.